Welcome to Very First Steps in IP. IP networking is a big part, as technology is concerned, of a digital broadcasting system, as for streaming on the Internet. IP for Internet Protocol, as you may know. Therefore, you would agree, basic IP knowledge is mandatory. An Internet Service Provider, or ISP, will install on your site a router modem to access the Internet. The network on your premises is called LAN for Local Area Network. From outside of your premises to the Internet, passing by your ISP installations, the network is called WAN for Wide Area Network. The DHCP service. It's a service available on a network that will send a network configuration, IP addresses, to a device requesting them. As an example, a PC in DHCP mode, the default mode, at boot or start time, will automatically request those IP addresses to be able to function on the network, and the DHCP server will send those addresses to this PC. DHCP for Dynamic Host Configuration Protocol. An IP address is made of 4 numbers, from 0 to 255, separated by 3 dots. Those numbers are the decimal value of a binary number, a byte. A byte is made of 8 bits. We have 3 addresses example here. This is the network configuration window for a PC. In this example, the default mode, the device will obtain an IP address automatically and also subnet, gateway, and DNS server addresses. There is nothing to configure by the user. In manual mode, the IP address of the device as well as the subnet mask and default gateway addresses must be configured by the user. As for the DNS service, the device, the PC, will still obtain those server addresses automatically. What are those DNS servers? Preferred domain and alternate or backup. The domain name system can be considered as the phone book of the Internet, translating domain names as www.myname.com to a valid IP address for data transport over the network, the Internet. IP addresses are split in classes or range of IP addresses. For the A, B, and C classes of IP addresses, a subnet mask is associated to them. In what is called a classful scheme, which is the case in our lecture, the number used in the subnet mask can be either 255 or 0. The 255 identifies the network part of the address, and the 0 identifies the host or devices on the network. In our class C, only one last byte, the last number of the subnet mask, is 0, meaning that only this last number will identify the devices on your network. Then, 254 devices can communicate on your network. But what if you need more than 254 addresses on your premises? Class B subnetting or supernetting of 2 or more subsequent Class C would be the solution. But this is way out of scope of this lecture and this course. In our Class C, the last number could be something from 0 to 255 for a total of 256 different values. But why only 254 addresses are to be used? Because we don't use 0 or 255 for the last byte. The permitted values are from 1 to 254 only for a valid address for this last number. Why can't we use 0 or 255 for the last byte or number? If this last number has a value of 0, this address of 4 numbers is used for the network identification, the network address. And if this last number has a value of 255, the address, or phone numbers, is used for the broadcast address to communicate to all devices on the network, a specific function not covered in this lecture. the router IP address. The gateway address is given to us by the ISP, the provider, being the router IP address. 192.168.2.1 in our example. The subnet mask is also given to us by the provider. In our example, it's 255.255.255.0, the last 0 being host specific. In my class C, all the devices of the network will have an IP address as 192.168.2x. The x will be a unique value for each device, not using the 0 and 255 as values, as we just saw. Back to the network configuration window. As we know by now, all the devices on that network will have a unique IP address from 192.168.2.2 to 192.168.2.254. The subnet mask is 255.255.255.0. And the default gateway is 192.168.2.1, the router address. Addresses allocation table, which could be a table in a text editor or a spreadsheet. It's important to plan which device will have a fixed IP address configured in manual mode and which devices will be in DHCP or automatic mode. They can be grouped by room or function with space between those groups for potential growth. Here we have an example. The DHCP service seems not to offer Wi-Fi to all members present in the sanctuary. That's correct. It's not the purpose of the service. A typical router. A router is linked to the WAN via the Internet Service Provider. On the LAN side, there is a link for IP telephony and 4 Ethernet ports in our specific example. To access the configuration pages of that router with a PC on the same network, its IP address should be entered as a URL on the web browser. This address is given by the provider. In our example, 192.168.2.1, which is the router address. The provider has also given a password which may be changed. There is no need for a login. Wi-Fi settings. This typical router example offers 2 services, primary and guest. For each one, there is a network name and a password to be set. Note that the Wi-Fi service can be disabled or only the guest network can be disabled. A Wi-Fi network name is also known as SSID, for Service Set Identifier. DHCP settings. Router IP and subnet mask addresses are already set and given by the provider. Only the DHCP IP range must be configured using start and end addresses as decided in the IP addresses allocation table. DNS setting is set by the provider as obtain DNS information automatically. For the church streaming service, a speed test should be done to assess the available throughput or upload speed. Note that the service is asymmetric, the download speed being higher than the upload speed. At 11 megabits per second, this site meets more than what is needed for your streaming service. The switch. The router has only 4 Ethernet ports, which is not enough. To have more, a switch as this Cisco switch must be used. Several models from several brands offer switches with 16, 24, and 48 ports. 4 88-port switches would offer 192 ports total. Here we have a small media network as an example. A router with Wi-Fi service, a switch, 2 media PCs, a camera link to one of the 2 media PCs, a file server, a laptop to monitor the feed on the social media page via Wi-Fi. A little difference here, the media converters, HDMI to IP for the camera and IP to USB for the PC, are linked via the switch. Just to say here, for cable installation, their specifications should be taken into consideration, not only for the streams, but also for the file transfers. A UPS should be used for network and media devices, mainly to protect the equipment. Church leaders should be aware of security and reliability issues such as software firmware update policy, system administration policy, login and password policy, device security software, remote control software, online technical service. That's it for very first step in IP. You are now invited to the OBS Studio demo.